Welcome to our Tech Days presentation on QGen, the automatic code generator for Simulink and Stateflow. We're going to be reviewing some of the new capabilities that we've been working on over the past year, and we'll also give you a short demo. First, I'd like to introduce our panel. I'm Tucker Taft. I'm the Director of Language Research at AdaCore, and I'm also an advisor to the QGen project. We also have a special guest from Vericel. Jim, can you introduce yourself?
Hi, this is Jim Shalini. I'm the president of Vericel, and we're working with AdaCore on the qualification of QGen.
And we have one of our lead engineers on the QGen project, Jose Ruiz. Can you introduce yourself?
Yes, hello, my name is Jose Ruiz. I work for AdaCore in the Paris office, and I am QGen technical lead.
Okay, so we're going to have a Q&A at the end, so I'd encourage you to start sending in your questions. And now we'll get going on our update on QGen. So we'll be talking about the QGen code generator, and one of the most important aspects of it is it's being qualified at tool qualification level 1, TQL-1. And this is an ongoing effort which has been occupying us greatly over the past year, and it's a very interesting attempt to create what we call a trusted code generator. And at the end of this, we'll also have a presentation of the additional tools that support QGen and make it a high productivity tool, in particular a model level debugger. And we'll mention that there are a few other tools for doing static and dynamic analysis of your models. So at the end, we'll be doing a short demo of our model level debugger and talk a bit about other tools such as static and dynamic analysis tools. So on the next slide, I'm just giving you a sort of a top level description of the things we focused on over the past year and what this means to your organization. Fundamentally, what we've been building is a trusted code generator. And what I mean by that is that you and the FAA and your customers and your ultimate users can depend on the fact that this code generator, given a Simulink Stateflow model, will produce an exactly equivalent set of software that will implement the semantics of that model. And one of the great features of a trusted code generator is that you don't have to actually look manually at the generated source code output. You can have a great deal of confidence that it is exactly equivalent to the model. And your testing will focus on the model itself and on the final application, but you don't have to spend a lot of manual effort reviewing the generated source code. This whole approach significantly streamlines the workflow of using this kind of code generator. It becomes essentially just the equivalent of a compiler. You never have to look at the intermediates that it generates. We are working towards a TQL-1 qualifiable tool. What that means is that in combination with your project needs, you can qualify this tool for use on a particular project, including projects at the highest level of certification. And because of the TQL-1 approach that we've taken, this will significantly simplify your use of this tool as part of your certification, and Jim will give you some more details on that. And one of the most interesting things that make this tool different from other similar tools is that we've adopted an enterprise-wide subscription-based license. And what that means is that a single qualified or qualifiable tool with its qualification kit can be used on multiple projects within your organization. You don't have to purchase separate licenses for this qualification kit. It's enterprise-wide. Furthermore, rather than just giving you a frozen snapshot with a particular code generator and version of Simulink and so on, we provide an annual update, which allows you to choose exactly which features you might want to add to your subscription, supporting additional programming languages, additional certification authorities, and so So there's a lot happening with QGen, and I'll let Jim take it from here in terms of talking about the TQL-1 activities. Jim?
Thank you, Tucker. So first of all, let's talk about qualified tools. Currently, they are qualified as part of a certification project. That means once the tool is qualified on an aircraft project, it has to be requalified on the next project. This is under discussion, but in order to support that, what we're providing with QGen is a tool qualification data package. This provides a hyperlinked full data set of all the qualification data to support QGen. This also provides an easy way for auditors to review that material in a meaningful way. They can follow the traceability through the artifacts, view the relationships, and they can see not only the artifacts, but the review of those artifacts. So how does this help you? If you're using Simulink or Stateflow, you also need to comply with DO-331, the model-based supplement to DO-178C. There's a large number of objectives that are required to satisfy this. QGen qualification is intended to provide support to more than a dozen objectives. So as you can see from this table, we provide coverage over design, code and integration, and verification objectives, greatly reducing your effort. As Tucker mentioned, this eliminates the need to go into reviewing the generated code. You can trust it and work at a higher level of abstraction. And also noted, we provide through the subscription service support to your qualification and certification project in the area of certification liaison. So if the authorities have questions on the QGen materials, we will help provide that information and support you. So what does this look like? So first of all, we're not following a standard DO-330 tool qualification approach. We're making use of the FAA's Streamlining Assurance Initiative on overarching properties. This allows us to establish a risk-based assessment and hazard analysis related to the impact of the generated code on the application. So rather than focusing on how the tool is built, we focus our activities on what the tool produces. That's what's going to fly. QGen itself doesn't fly, the generated code does. The way we present this evidence is again based on the overarching properties established through a structured argument to focus on intent, correctness, and innocuity. So basically, what is the code intended, what is the tool intended to do? Does it do it correctly? And if it has aspects in the tool itself that are not traceable to desired behavior, we show that it has no effect on the output. All of the lifecycle data is provided through hyperlinks in this tool qualification data package. The example here shows just the navigation from the left side, but it allows the user to walk through the argument to the supporting evidence, or through documents, through the HAZOP, and even through the requirements. So you can trace the requirements to the reviews to the verification. So why do we care about subscription? You have fewer surprises. It allows for planned updates. You're not frozen necessarily on a particular version. As Tucker mentioned, there's yearly updates. You can choose to take the next update or not. This allows you to pick up new features as they're introduced, whether it's fixed point support, ADA, new extensions to Simulink blocks, that are supported. So over time, your projects can evolve in a controlled manner and with controlled costs. And with the subscription, tool and qualification support is included. Thank you.
So thank you, Jim. And now we're going to talk a little bit about the tool suite that comes with QGen. And in particular, AdaCore, as you may realize, is coming at this code generation to some extent from below. That is, we've been providing compilers and debuggers and so on to projects that are building safety critical systems for our entire history. But as model-based development has become more important for these kinds of projects, we have been developing this QGen code generator over the past decade or so, and we're now bringing it to fruition. But we get to take advantage of all of those other tools that we've been developing for years. In particular, we do have C and Spark Ada compilers, so that whether you choose to generate C or Ada, you can use an AdaCore compiler or other compilers. We're generating very standard output in terms of MISRA C and the Spark subset of Ada. So it's something that can be compiled by other kinds of compilers if you have other vendors, but it also is something that integrates very nicely with AdaCore's compilers and debuggers and so on. Furthermore, we've enhanced our standard debugger to also now allow you to work with model-based systems. And we have a short demo coming up that will show you how that all works, how you can actually see your model, see your generated source code, and see even the assembly code if you want to get to that level. And finally, there are a whole set of other tools that AdaCore has developed over the years, some focused on source code, but now also some of those have been augmented to support model-based development, and those will also be available in a growing number over time. So all of our tools will ultimately be part of this tool suite. And at this point, I'm going to hand it over to Jose, who's been part of the QGen team from practically the beginning, and he will show you what other things that you can do with this model level debugger. Thanks, Jose.
Thank you, Tak. So I'm going to talk today about what Tak mentioned is about the QGen debugger. Basically, the idea behind this model level debugger is to be able to show you in a single place a representation of the evolution of your models while you can see the same evolution in your source code. So it helps a lot in bringing together teams doing software engineering, teams doing system engineering, because you have in the same place the view where they are more comfortable. So here in the screen, you can see in the middle, there is the model representation. It is our own representation of a Simulink model. We respect the location of the different blocks, the names, so that you can easily recognize your original model. To the left, you see the code that corresponds to this piece of the model, so that you can see what it corresponds in terms of code. And if you want, on the right side, you can see the object code if you're interested into how things are going at the very low level. It is a very helpful tool to do the integration between your automatically generated code and your manually written code, because at this stage, you have everything at hand and you can debug and you can do anything that you want at the model level or at the source code level. And you can do the typical things that you can do in a source code debugger, like stepping through your code, looking at your variable, but you can do exactly the same thing at the model level. You can step through blocks, you can look at the values of signals, you can change the values of signals, etc. And that we will see quickly in a demo that I will show you. Another advantage of this technology is that it's based on debugging technology, so that you can connect to your target. So now the demo that I'm gonna do will be done on my local host. But if you have your final target on your cross compiler, you can just set it up very easily so that you connect the executable to your target, and you can do model level debugging or source code level debugging on your target. So that is the thing that I will show you in a moment. Okay, so here we are in the Simulink environment. You have your model. In this case, it's a car system, but it doesn't really matter. The idea is that I want to show you how to debug this model and the generated code in a very easy way. So we have Kyogen has an integration within the Simulink environment where you can do many different things. Obviously, you can generate code, you can check compatibility against the subset supported by Kyogen. But what we are interested today is to create a debugging session. So we click here, and we are automatically creating a wrapper around your model so that you can feed some inputs and get some outputs from your model. Here, for example, you can use a signal builder to select the inputs that you want to feed to your model. Okay. Once you are fine with the inputs that you want to use, you can click on generating the debugging session. So here it's asking me whether I want to use the simulation to feed the model. I say yes. So at this time, what everything is doing is basically we are simulating the model with the inputs that we have created. Everything that is inserted into the model is being logged. All the inputs are being logged. All the outputs are also being logged. And the goal of that is to log the inputs so that we know what to insert into the generated code to, let's say, animate the code. And on the other side, on the output side, we are reading the results produced by the generated code. We are comparing the results against the results that we have a simulation so that we can verify whether there is any deviation when you are running your generated code. So now we are waiting until the creation of the model, well, the simulation information. Now everything is recorded, so we are going into the code generation phase. We use the default values. We are opening our IDE, our GNAT Studio IDE. Kyogen can generate either C or Ada. Let's see that for this session, we'll use C. We have already a project so that we don't need to recreate. Okay. So now we are ready to create the debugging session. So we can go into clicking into a button that will do the generation of the code, the compilation of everything, and the connection to the debugger. So this is what the tool is doing right now. Okay, here we are. Now it looks like what I showed you before. On the right-hand side, we have the model level representation. On the left-hand side, we have the source, the generated code. We can do things like, for example, navigate through the model. And let's say I want to see the behavior. I mean, I want to see the details of the behavior into this part of the model, so I can set a breakpoint. The block where I set a breakpoint changed color, so it's getting red. And we can start now the debugging session. So we click on start, we run it. Okay, and now here we are, everything is executing. We see this arrow indicating where we are. We are just at the beginning of the code. If we click on continue, now we hit the breakpoint that we set. You see the red block that indicates that we had a breakpoint. Now there is a green line around indicating that this is the block that is being executed. On the left-hand side, you see the same thing. You see the concrete line of code that is being executed. And you can do things like in any regular debugger, you can execute step by step and see what happens. So on the left-hand side, you see how the arrow evolves. You click again. Now we are going to finalize the execution of the block. So now the block has executed, and now we see on the right-hand side that the signals have been updated. This is a saturation block where the input and the output are the same, so it means that there hasn't been any saturation. Now you can click on continue. You will hit the breakpoint again, but now we want, for example, if we want to check whether saturation is working and whether saturation gives me the results that I want, I can force when I'm debugging, I can force this condition by, for example, enforcing the value of this signal. So this signal, we can change it on the fly. Now, I mean, by the execution of the model, the value of this signal is 9.4, but I can change it to a value that I know will saturate. For example, if I set it to 100 and I apply, you will see on the right-hand side, everything has been updated. So now we have a value 100 as input of the saturation. We can execute step by step again, and we can see the result. So now the block executed with an altered signal input. We had 100 as an input, but it saturated up to 50. And this is the way you can enforce conditions that are difficult to trigger during normal execution of your model. And then you can verify whether some parts of the models that are there, for example, for robustness, you can force that behavior and check whether the behavior is the one that you expect. The breakpoints, of course, you can remove them, and you can continue execution. As soon as you move execution, you will see the updated information on the left-hand side. On the code side, you will see the arrow indicating what we are executing. On the right-hand side, the same thing. We moved to another scope, so we are now executing a different block. So this is the kind of things that you can do with this debugger, and also you can do that, as I mentioned, on your final target, if you wish. So that's all that I wanted to show. Just letting you know that if you have any questions, I'll be there to answer.
Thank you, Jose. And as you've heard, we've been working very hard on our TQL-1 qualification and also the overall tool suite that's available with QGen. And thank you very much, Jim and Jose. And we look forward to your questions, which we'll be happy to take. So please, if you have any other questions, do send them in now.